Welcome. Hopefully you guys had a good Memorial Day. We are here, the very final week of school, and yeah, had a great time working with you this year. Just a little bit more to get through with coordinate geometry. And this section here, this is from section 11.3, I believe, of the textbook. Yes, your homework will be in section 11.3, and this is going to be the midpoint formula. And this is an important one just to use this formula that you haven't gotten to yet, right? So I'll put a little question mark here. What is the midpoint formula, okay? Given a segment, if we know the, think about what points would be most significant of a segment on the XY axes. So I'm guessing you're probably thinking the endpoints of a segment. And that would be important to getting us to our midpoint. So today I'm going to talk about how we prove a formula when given the endpoints of a segment, how we can determine the midpoint of those segments. And this will be useful when we get to coordinate geometry proofs, which will be later this week. Let's get started, guys. Okay, so I think you probably heard that your homework tonight's going to be in section 11.3. You should read that section as part of your homework, but because this is actually pretty easy, the midpoint formula is a pretty easy one to remember, I figured we would have just some other things to look at, to consider with the midpoint formula. This would make that sort of learning about the midpoint formula a little bit more memorable and a little bit more real world applicable rather than something that you just learn for a second, you do some problems, then it goes in one ear and out the other, which you don't have that here. Okay, so I got a couple of little tasks we're going to do with this here. The first of which is called a snack in the middle. Get it? Middle, midpoint? Anyways, let's get started here to seeing how this concept is being introduced to us. Maddie and Clyde are pruning trees in an orchard that's arranged in a grid. Each tree is identified by its coordinate location. Okay, very good. So it looks like we have a grid. So we probably have some sort of an XY action going on here. 2 dimensions because it's kind of a grid. Every afternoon, they choose 2 trees that need to be pruned the most, and each of them works on one of those 2 trees. Pruning makes Maddie and Clyde hungry. They decide to set up a snack table at the midpoint of a segment connecting the 2 trees they are working on. That makes sense. We got to work on these 2 trees. So here's where my snacks are going to go. If there happens to be a tree at the exact points, they will set up the tree table right next to that tree. So at that point, Interesting that they had to qualify that for this. Anyways, let's do number 1 here. Suppose Maddie is working on a tree at 24.6 and Clyde is working on a tree at 30.14. What are the coordinates of the point where they should set up the snack table? Prove your choice is really equidistant from 24.6 and 30.14. Okay, so it looks like we're dealing here in quadrant number 1, and these points are pretty close to one another. So I might just do a L graph here to make it a little bit, spread the points out a little bit more than what we have here, okay? So let's say maybe this is 30, and maybe then this is 24, and then let's say maybe this is 6, and this is 14, because these are your y coordinates, 6 and 14. So that means on the grid, we would have a tree like right here, and we would have another tree right here. And we want to set up the snack table exactly halfway in between. So we're going to mark our midpoint, and we need to figure out what the coordinates of that midpoint is right here, okay? So what are the coordinates of the point where they should set up the snack table? What do you think? Well, let's go with our best guess, okay? Before we actually prove this here, let's go with our best guess. What do you think, okay? So our midpoint here, remember this is 2 dimensions. So do you think it's going to be right in between this 24 and 30? Let's maybe mark that down. You know what? I think that's a pretty safe guess. Look at this here. That looks like halfway in between the XY axis. So the left-right dimension, about halfway in between there. Okay, so it looks like 27 could be the X coordinate. Let's lock that in. What about the Y coordinate? Okay, well, it's going to be higher than 6, less than 14. Do you think there's going to be a pattern there? I think so. Okay, so I think it's probably going to be a 10 because 10 is exactly halfway in between 14 and 6. Okay, so is it just the average of the coordinates, of the y coordinates, average of the x coordinates? Well, if so, that would give us our midpoint formula. Okay, 24.10. So let's see here. It's not asking you to prove the midpoint formula right now. It's prove to see your choice is really equidistant from 24.6 and 30.14. So I think what this means is here, and I always get questions about this when I give this one, is what does this mean prove? Well, you got to use the distance formula, right? If we can use, our goal here is to prove that distance from 24.6 to 27.10 is the same as 30.14 to 27.10, then just use the distance formula to show that. Okay, so let's do that. All right, distance from tree number 1 to where we think the midpoint is going to be square root 24 minus 27 is negative 3. Square it. Plus 6 minus 10 is negative 4. Square it. So we'd have positive 9. Negative 3 squared is positive 9. Negative 4 squared is positive 16. So that's the square root of 25. And the principal square root of 25 is 5. So our distance is 5 away. And what about D2? Well, in terms of the x-axis, it's going to be 3 units away because 30 minus 27 is 3. 30 minus 27. So this is x2 minus x1. 30 minus 27 is 3. Square it up, and then add 14 minus 10 is 4. 4 squared. And yes, this is also going to end up being 5 because 3 squared is 9, 4 squared is 16. So this would again be root 25, and that equals 5. So it's proven through the distance formula these are actually equidistant. Okay, so that is step 1, right? Step 1 to proving the midpoint formula is, well, 1 is the midpoints, and I'll put that in quotes, equidistant from endpoints. You might be thinking, Mr. Fortin, we done? So we just got started on homework right now? We've proven what we needed to prove? Well, have we actually proven this is the midpoint yet? Well, this was just a conjecture. I tossed this out here. Why don't we try 2710 as a potential midpoint in between these two things? What would also have to be true about a midpoint of a segment in addition to it being equidistant from the endpoints of the segment? Okay, so again, we don't know if it's the midpoint. What will be true? Well, what have we just proven here? Well, we've proven that this point is equidistant from that point and that point, but wouldn't all of these points too, right here, okay, all of these points here, and I'll do that with a solid line, wouldn't all of these also be equidistant from the endpoints of the segment here? What did I just try to draw in? Oh, that's right, the perpendicular bisector, okay? So all we've proven about 27 and 10 is that it's on the perpendicular bisector. What haven't we proven yet? So we know it's on perpendicular bisector. Have we proven that? How we know? So we know it's on perpendicular bisector, so it could be up here. What's one way we can prove that it's actually this point? Oh, okay, cool. Step 2. Okay, so step 2 of proving this is that it's on the line containing the endpoints. Okay, so the two endpoints here are 24, 6, and 30, 14. And through 2 points, make exactly one line. And your midpoint between those 2 points needs to be on that line in addition to being equidistant from the endpoints of the line. Okay, so that's step 2 to proving this. We'll get to that a bit later. All right, another question here. If they're working on trees at -3, 4, and 5, 12, where should they set up the table? Prove your choice is equidistant from that. Okay, so let's see here. Let's get this as, well, in between 5 and 2. Well, let's add them together. You get 2, divide by 1. I'm going to go with 1, okay, because that's 4 away from -3 and 4 away from 5. Good. And then let's see here. 4 plus 12 is 16. Divide by 2 is 8. So the trick here to getting exactly in between would be to add the two coordinates together and divide by 2. And then 4 is 4 away from 8. And 12 is also 4 away from 8. So 1, 8 is what I got here. Okay. Distance formula. Okay, I got -3 minus 1 is -4. So I got square root of 16 plus 4 minus 8 is -4 plus another square root of 16. Okay, let's try distance 2. Again, I got 5 minus 1, that's 4. 12 minus 8, that's 4. So square them both, 16 plus 16. So D1 equals D2 through transitivity here. So we're good to go there. Same distance, okay? Do we know 1/8 is the midpoint of the segment again yet? And yet, no. We know it's on the perpendicular bisector of that segment, but we don't know if it's actually on the segment connecting -3, 4, and 5, 12. If they're working on trees at 6, 2, and 11, -4, where should they set up the table? Prove it. Oh, man, they're making you practice using this distance formula quite a bit. Oh, gosh. You're like, Mr. Fortin, why give me this Common Core stuff? Oh, stupid Common Core. You have to see the same thing over and over again. It's too easy. So we're going 8.5 here, right? Add the two coordinates together and divide by 2. And add these two coordinates together. So we get -2 divided by 2 is -1. And then prove it. I'm just going to move on with my life. You can move on with your life too. To save you time, make up a general formula for Maddie and Clyde. Suppose the trees they are pruning at x1, y1, and x2, y2. Find a formula for the midpoint between these two trees in terms of x1, y1, x2, and y2. This is called the midpoint formula. Okay, so let's put this in here. So a midpoint of x1, y1, and x2, y2. Well, we got to figure out exactly halfway in between the x coordinates, okay? So what we need to do is this. We need to do x1 plus x2. And what do we need to do to that? We need to average them, so over 2, okay? So this is the formula for finding the x-coordinate, and just like this is the formula for finding the y-coordinate. And this, my friends, is the midpoint formula. Have we proven it yet? No, we haven't proven it yet, okay? So I'm going to write this up top here, proving the midpoint formula. I'm going to write this. The midpoint formula is, maybe I'll write it over here. Midpoint formula is this, that if we have 2 points, x1, y1, and x2, y2, then we can average the x-coordinates to get the midpoint, to get the x-coordinate of the midpoint, and then average the y-coordinates to get the midpoint of the y-coordinate of the midpoint of those 2 segments. Okay, there's our formula. We've proven, right, kind of through this logic here of just repeating of doing this here, proven that the midpoints, what we think is the midpoint, if we follow this formula, is equidistant from the endpoints, but we haven't yet figured out that it's actually on the line containing the endpoints. That might be in part 2 here. All right, on to page 2. On page 2, this is where we're going to get the proof of actually figuring out, is this formula, the midpoint formula, is it a theorem? Can we use it? Can we prove it? In the activity of Snack in the Middle, you were asked to find the midpoints of the segment connecting 24/6 and 30/14. The answer is 27/10. Yes, we did all that, right? Part of the task was to prove that 27/10 is equidistant from the 2 endpoints of the segment. Did we do that? Yeah, we used the distance formula. We did prove that it was equidistant from the endpoint segment. Unfortunately, this doesn't prove that 27/10 is the midpoint, because any points on the perpendicular bisector of the segment will be equidistant from the 2 endpoints. So all we've done is prove that 27/10 is on the perp bisector. We haven't proven yet that it's actually on the line, right, on the segment itself that we say it's the midpoint of. So that's sort of what this assignment's going to be. Okay, so just to show you here that we haven't done, right, 27/10, all we know is it's equidistant from the endpoints. This first question is asking, well, what are 2 other points that, right, could be just like 27/10, in that we would know that they're equidistant from 24/6 and 30/14. So remember, the midpoint is unique. There's only one midpoint. So there are other points that are also equidistant, so we don't know enough to get a unique point yet, okay? So where my brain goes with this one, this might be the hardest question on here, on 2 other points that are equidistant from 24/6 and 30/14, means find more points that are on the perpendicular bisector. So this is a tricky question, because what we need to do is, we know that 27/10 is on the perpendicular bisector. We need to come up with the equation of the perpendicular bisector so we can get more points on the perpendicular bisector here, okay? So the criteria for that line, the line of the perpendicular bisector of the segment, is, 1, it goes through 27/10, and it's going to be perpendicular to the segment that you draw between 24/6 and 30/14. So if it's perpendicular to that segment, the slope needs to be the opposite reciprocal of the segment itself. So let's start with maybe actually coming up with the equation of line through 24/6 and 30/14. We'll start there, then we'll come up with the equation of its perpendicular bisectors. We have enough information from that. And 30/14. Okay, kind of messy there. All right, the format of the equation I'm going to use, I'm actually going to use this format. You probably haven't used this too much yet, but it's a format, a special format for the equation of the line called the point slope formula. Okay, I know that probably all you guys are good enough at math to know what the y equals mx plus b equation of this. It would require a few more steps than the point slope formula. But this is called the point slope formula, and it's something that I normally have more time to review in sections 11.4 and 11.5, but we're skipping over those sections. 11.6, we're skipping over that one too, because I want to get to coordinate geometry, coordinate proofs before the end of the week, which is the last week we have, right? So anyways, coming up with an equation like this is actually a valid way of coming up with an equation that goes through these 2 points. And the nice thing is, we have the points, so we can actually start plugging into this equation. Because let's say that 24 is x1 and 6 is y1 in this arrangement right here. So we can do y minus y1, which is 6, equal to m. We don't have that one yet, but we can quickly get that in a second. X minus x1, which is 24. Okay, so we don't have m yet, but if we have 2 points, you sure as heck better believe we can figure out what the slope is. So given the slope given 2 points is, that's why we have the algebra 1 tattoo, y2 minus y1 over x2 minus x1. So y2 is 14, minus y1 is 6, and that would be 8. And x2 minus x1 is 30 minus 24, which is 6. So our slope here is 4 over 3. Okay, and I do all that. We'll need this actually later. We'll need this in part 2. But I do that because we want to use this. This slope right here is going to be related to the, let's get the perpendicular slope to this, because the perpendicular slope of this is going to be the negative reciprocal of what we originally have. If this were m, if m were 4 over 3, then the perpendicular would be negative 1 over 4 over 3, which would just be negative 3/4. So the perpendicular slope is the opposite reciprocal of the line it's perpendicular to. So negative 3/4 to a 4/3 slope. Those would be perpendicular to one another. Okay, so it's asking to get 2 other points that are equidistant from 24/6 and 30/14. So what it means is points that are on the perpendicular bisector. If we have the equation of the perpendicular bisector, we can figure out 2 points here. And we can get the equation because we know that 2710 is on the perpendicular bisector and we have a slope. So we can use that thing that I was just telling you about, which is the point slope formula, to get that equation. Okay, so I get y, and then y1 here is going to be 10. So y minus 10 and equals, and then the slope is negative 3 over 4 times by x minus, and x1 would be 27. Okay, so now we just need to plug in values for x and then solve for y, and do that twice to get 2 points. Another way that I can think about it is actually, since 2710, you can actually just use slope to get your answers here. So if 2710 were on the perpendicular bisector and the slope is negative 3/4, what you could do is you could take away 3 from the y. So remember, a slope is rise over run, so take away 3 from the y, and that would be 7, and add 4 to the x's, that would be 31. So 31/7 would actually be on the line, because the slope here would be minus 3/4, right, from this. So take away 3 from 10 and add 4 to 27, and this would be on the line. Another point, if we just repeated that again, that same logic right there, that if we added 4 to the x's, we get 35, and took away 3 from the y's, that would also be on the perpendicular bisector, and thus be equidistant from the 2 endpoints of the segments, where those 2 trees are in the orchard. Okay, number 2. Explain how you know that 2710 is actually on the line segment connecting this. Okay, I think we got this. To do this, you will need to find a linear equation whose graph includes those 2 points and show that 2710 also fits the equation, okay? So that's why I did this work up here. We already have this equation. It's up here, right? That's it. And then they say a linear equation. That's supposed to remind you there are several forms. You might have found the y equals mx plus b form of the equation that goes through those 2 points, 24/6 and 30/14, and that's fine. This is faster. This is easier for me. I got it using the point slope form. So that's what I'm going to use over here to figure out if 2710 is going to be on this line. So I got my x value, got my y value, just got to plug into this equation here. So I plug 10 in for y, take away 6 from it, plug in 27 for x. Take away 24 from it, and then we have to deal with that slope of 4/3 here. This simplifies down to 4, and then I'm going to get 4 over 3 times by 27 minus 24 is 3, and that's very nice. 4 over 3 times 3. 3's cancel out. Yes, I get 4 out of 4. This works out. Yes, it does. Hooray, it's on the line. So I've proven this. How would you prove in general that the midpoint formula actually gives the midpoint? Well, I talked about it at the beginning. 1, is it equidistant from endpoints? And 2, is it actually on? If you're both equidistant from the endpoints and on the line containing the endpoints, right? There's only one point on the line containing the endpoints that's equidistant from the endpoints, and that's going to be the midpoint. So by going through this exercise and showing that 2710 was in fact the midpoint, let's bake this in here. This is our midpoint formula. This is what we're going to use. Remember, we found 2710 because we averaged our x coordinates. We did 30 plus 24. and divided that by 2 to get 27. And then we averaged our y-coordinates. We did 6 plus 14. And then we divided that by 2 to get 10. And this is our midpoint formula. And then we proved that was on the line. We proved they're equidistant. So let's accept this. We'll consider this a theorem. All right, and let's wrap this up with the third Common Core assignment you have for today, right? We're going from the Common Core today for this midpoint formula because it's so easy, right? You're just averaging coordinates. That's it. Adding the 2 coordinates together of the endpoints, dividing by 2, boom, you found the midpoint. Another way to think about the midpoints, though, is midpoint high school. That's right, midpoint high, hooray. Quadrant city, ha ha ha. So funny quadrants. We got quadrant 1, quadrant 2, quadrant 3, quadrant 4, ha ha ha. Anyways, of course, we're in coordinate geometry, so you got your axes, and they divide the plane into 4 quadrants. But anyways, it's building a new school called Midpoint High. It's going to serve as the city's districts A and B. And public officials want to make sure that both districts are equidistant from the new school. Okay, so I think you have an idea. The new school needs to be on the perpendicular bisector of segment AB. Okay, but they probably want it to be the closest possible, so they're probably just the midpoint of this segment AB here. Anyways, let points A and B represent the 2 districts. Connect them with a segment. Okay, so we want our midpoint high to be on that segment right here. That was ugly. Let me actually redraw this and see if I can do this as a straight line. Give it to me. No, it's not giving me a straight line. And there we have it. If a school bus can only travel horizontally and vertically because the streets are all lined with a grid, okay, fair enough. The city streets are usually with grids here, right? You got east-west streets and you got north-south streets here. How far will the bus have to travel to get from district A to B horizontally? How far vertically? Okay, maybe this is getting us think about how we can actually maybe use slope to figure out a midpoint. I don't know. Okay, so horizontally, this would have to be the absolute value of x2 minus x1, or it might be x1 minus x2. It doesn't matter if it's absolute value. And that's going to equal 20 minus negative 40. So this is going to be 60. Okay, so got to go 60 here. Okay, so this slope triangle would have a delta x of 60, delta y, and y is increasing, doesn't matter because, again, absolute value of y2 minus y1 is what we got here, and that's going to be 25 minus negative 5, so we got 30 here. Okay, so we're going to go 30 and then 60, so horizontal travel 60, and what's it in here? Do they actually have units here? They don't have units. Well, it's quadrant city, so whatever. They don't need units. They just need the ruler postulate to say this is 10 units, or 5 units, 10 units. Anyways, vertical travel will be 30 units. If the bus only travels half the length horizontally and vertically, starting from either district A or B, what coordinates do you end up on? Label this as point M. Oh, interesting. Okay, so it's having you taking this alternate approach to figure out what the midpoint is, maybe proving it here. Okay, so we only want to go half as far, so we got to figure out what's half of 60. Oh, that's 30. So if this is 25 here, ooh, 20. Do we want to go 30 from, we're starting at 20 right here. Sorry, 20, and then we want to go 30 from 20, so that would bring us to negative 10. So this would be half the distance here. And oh, look, did we actually end up on the midpoint? Let's see this one here. This point here would be negative 10, positive 10. That's the coordinate you end up on, and I'll label it point M. Is that the midpoint? Ooh, it might be. Verify that M is the midpoint of AB by showing the 2 things that are required. 1, M is equidistant from AB, and 2, M is on the line that goes through A and B. Line that goes through A and B, it's easier to find the equation here because you can do it in slope-intercept form because we can figure out the slope. Slope's going to be 30 over 60, so that's going to be 1/2, and x, and then we have a y-intercept at 15. And so I'm doing this first part first. We're going to plug in 10 for y and negative 10 for x, and this will work out. 1/2 times negative 10 is going to be negative 5. And negative 5 plus 15 is 10. 10 equals 10. Consider that verified, that it's on the line containing a segment AB. And equidistant, sure, that's the distance formula. So we got to do root. So this is going to be BM, distance BM would equal root. We'll do our x's first, 10 minus negative 10. Sorry, I made 20 minus negative 10. squared plus our vertical distance, square of the difference in vertical distance, which will be 25 minus 10. All right, so we got 30 squared, which is 900, plus 225, which is 15 squared. 25 minus 10 is 15 squared, okay? So that would be root 1125. And let's see if that matches AB using the distance formula. AM using the distance formula. Looking pretty good here. We're going to end up with negative 30 squared, and that's going to be 900. And then we add to that the other leg of this slope triangle, which is going to be the y values here, 15 squared as well. So that's going to be 225. So we get the same thing. We get square root of 1125 for the distance AM. Okay, so through transitivity, so distance formula gets us the distances AM and MB, and through transitivity, we know that they're the same because they both equal the same thing. They both equal root 1125. So we're good to go. M is the midpoint of AB. Hey, works out, continues to work out here. Okay, tricky last question. At the last board meeting, those board meetings, you can listen to them online. Those board meetings have been in the news recently here in San Francisco. But some members argue that because District A has more children than District B, they should get some priority here. Midpoint High should be built at a point P that's closer to District A. Hey, you're servicing more kids there, and why make them travel quite that far? How far would the school bus have to travel horizontally and vertically from A so that AP is 1/3 of AB? What would be the coordinates of P? And then finally, what would the coordinates of P be so that AP is equal to 2/5 of AB? All right, so we're going to get a coordinate P here. Maybe we'll do P prime here and P double prime down here so that we have two P coordinates going here, okay? So we want it to be 1/3 of AB, distance from A, and A's right here. So we need to do 1/3 of, let's go with just the 1/3 of the vertical distance. The vertical distance is 30, then we just need to go up 10 and then draw over. Instead of going over 60, we're going to go over 20. So here, this is going to be point P, P prime. Okay, what if it were 2/5 of AB? Coordinates of B double prime B, so that AP is 2/5 of AB. Okay, so what's 2/5 of 30? That would be 60 divided by 5 would be 12. So we go up 12 instead and cut over. What's 2/5 of 60? 120 divided by 5. Let me organize my work here real quick. Plus 12, we go up 12 instead of up 30. And then 2/5 of 60. So you do 120 divided by 5. It's 24. Yeah, I could have just doubled this for my slope triangle right there, okay? So anyways, P double prime, get those coordinates going. So it'll be, the x is 24 more than negative 40, so it'll be negative 16. And the y coordinate is going to be 12 greater than negative 5, so it'll be positive 7. Up top, we never wrote the coordinates down. P prime is here, and it's going to be negative 25. Yeah, so this is just going to get you thinking about, hey, maybe there's some other formulas here for a ratio of distance that's not 1 to 2. So we're kind of halfway in between. Maybe two-thirds of the way away from something. There might be some other formulas that you can study. We're not going to study in here. It doesn't have any questions about it here, and your book doesn't really go over this. But yeah, there'd be ways mathematically to figure this out, which you could study if you had the other textbook, for instance, the white textbook does this, but we'll leave it at this. Okie doke. Here in section 11.3. So you're going to read those pages and then do the problem set, do the classroom exercise. You can do 1 through 10 all, and then you got a bunch of written exercises here. Let me erase the self-test. There's going to be too much work. You have to do the self-test too, so I'm going to push that back to Wednesday's homework actually, and then go on to this. Okay, so I already have it ready to go. I might put this in Google Classroom so that you can check your answers as you go along, but just getting practice using that midpoint formula. Good luck on this, guys. Take care. Email me if you have any questions. Bye-bye.